Okay. Good afternoon, everybody. I think everybody must be tired after such a long day, so I will do it very simple. I don't have very many formulas in my presentation, skip them. I will start very... what is the problem?
Maybe we could use this one.
Now it goes. Okay. First I'm show you about the accidents and the effects on structures. Oh, this is not the wrong one. This is okay. So we have heard a lot of data today, and data, as you have seen, is a problem for itself, especially if you are dealing with accident data. Then accident data are produced. In reality, no data exists. We make data, and it depends how we make it. The second important thing is that we have to know that data is reflecting always some indicators of behavior. And in our case, it is the system behavior. The system is the city with the people and all the other things. And the most important thing is what is determining the behavior. It are always structures. And this is the system of situation. So we can only change data and change behavior if we change the structures. The whole discussion was about changing data, less accidents, more safety. So this is only possible if we change the structures. I am dealing today mainly with urban structures, and it depends how we interpret data and structures. So we are familiar with only one mode. This is walking. We went up on two legs about 6 million years ago, and this is the speed. This is the energy consumption. And if we want to move fast, which goes in this direction, our body tells us, well, you are using too much energy, so you have to slow down. And this is the secret how we can control safety and whatever it is. It is a negative feedback. Negative feedback is life supporting, and this is important. And the human brain is a part of the control system of our body. And the outcome is this wonderful historical city. This is the human scale city everywhere on the globe. This is a European example, but you can find examples in Africa, in Asia, everywhere, where you have urban societies, or you have village societies. This is the human scale. There is no other human scale. This is important to know. And this is the space used for mobility. You see, for the last 200 years, for 6 million of years walking, this is space in square meter per person. And this is for cycling, for walking speed of a cycle and 30 kilometers of a cycle. And in the 19th century, we invented public transport. And this is the space used for buses or trams on the surface with only 30% occupancy rate. This is not a full bus. This is not a full tram. This is only 30% occupied. So 100% would be less than 2.5 smaller. So this was the situation in the last 200 years, and at this time we invented the new kinds of modes, mechanical modes. These are very fast and strong modes, but they have no brain. This is the problem, so we have to compensate the brain, and we have put some control speed in this. This we have forgotten when we introduced the car into the cities. And this is the space used by cars. You see down the small square, this is for parking. And as soon as the cars start moving, it eats up all the public space. And then we are wondering that we have congestion if we don't have enough space provided. And what are engineering doing all the time? They provide more and more space and encourage people more and more to use the car, and we kill the city. This is a treatment in the last decades. So we have converted the city from an efficient, safe situation into an inefficient and risk-prone situation, which is not sustainable, and we are complaining about this, and we have a social exclusion. This is civil engineering and urban planning of the last 200 years. And the car is not only outside, it goes in our brain. I will show it a little bit later on. It sits in our brain, in the center of our brain, and control everything what you see, what you think, and what you value. And this is the typical human scale city. The same scale on a car scale is this one, or this one. And this kind of urban planning and transport planning of the last 200 years has no scientific background. This is folklore, as Brian has explained. And this is the dominating folklore of engineering in the transport sector of today. So if we look to the speed, this is the speed in kilometers an hour, and this is the urban history and our experience of 6 million of years walking. And you see what is going on. We were walking, and then the 200 years happened. And now we are extremely fast. But our senses are not developed for the high speed, so we haven't understood what is going on. We can build the system, but we haven't understood it. And then we are wondering that we create a lot of effects we don't want. We have no experience for this speed. We can do it and operate it. And then we are complaining about 1.4 million killed people every year. This is an artificial system. The people are not dying from some miracles. It is a man-made killing by transport modes. And well, this is a rather safe mode because railways are a closed system, but this is not a closed system. This is an open system. You can go with the car wherever you want, you can stop it wherever you want, but this is not possible with the railways. So, the perception, well, do you understand what is here? Give it some sense for you? No? This one? No? This one? No? This one? No sense? This one? What is the difference? Speed. With each step you are losing half of the information. Okay? And how big is the risk? To make mistakes. And you see, this is the problem. We are not very well equipped to survive in a natural environment, so we change the environment. We reduce the informations in the environment, which means we destroy the nature, we destroy the city to move fast. This means we build carriageways, big carriageways, we build motorways, but we kill the city. Well, the situation has not changed very much. This is the accident figures over the last, I think, 100 years. And we believe that our mobility has increased. This was my belief also well, I became professor in the traditional transport planning, telling all the folklore tales. But mobility is not car moving. Mobility is going somewhere with some purpose. And if you fulfill a purpose with your car, you cannot move at the same time as pedestrians, as cyclists, or public transport users. So the number of trips per person per car is globally the same, more or less about between 3 and 4 trips per day in the system. It is changing over your lifetime. But in the system, everywhere on the globe, everybody in the average number is always about 3 to 3.5 trips per day. If car trips increase, pedestrian, cyclists, and public transport trips decrease. The number of trips is constant. Only if the number of people is increasing, then the number of trips is increasing. But it don't change, the number of trips don't change with the number of cars. So mobility is not driving a car. If you count only cars and you give mobility no sense, well, senseless mobility is unlimited. So this is the situation, but this is the basis of our traditional transport belief. This is the increase of speed. This is the Austrian situation. Germany is similar. In the 1950s, this is the walking speed, the red line. And in 1955, we had more or less no cars. We had some bikes. After the World War, everything was destroyed. And then we motorized. And 30 years after, in the 80s, we were about 10 times faster. This is the average speed of individual trips in Austria for all the people, everywhere, as pedestrians, cyclists, motorcyclists, and car users. And you see we have been about 30 years after about 10 times faster. So if we save time by increasing speed, the Austrian must have a big surplus of time over this thing. And the Chinese today must have even more surplus of time because you are so fast now driving on the motorways. You have built a lot of motorways. So the life in China must be much more convenient than it was 30 years before. You have no stress today, probably. Okay, what is happening if we are looking to the surveys? This is the time people spend for every trip, and these are the pedestrian distribution here. This is the pedestrian, 3 kilometers from house to house, and this is the travel time distribution of pedestrian trips in a city, any city you can take it. You get always the same figures. And you see the cars are about 6 times faster. If they would 6 times faster and they would save time, they must be on the left side of the pedestrian. And you see they are not on the left side of the pedestrians. They are more or less on the same situation. These are the cars. Travel speed for cars is 70 kilometers an hour. For pedestrians is 3 kilometers an hour, always house to house. Okay? So what is happening? If the speed is increasing, distance is increasing. The purpose is the same, but the distance is longer. And if we have every 5 kilometer counting station, then you have to count the car trip 5 times, but you have no counting data for pedestrians, no counting data for cyclists, which is the normal situation. This is the situation today. What is happening here is this was the old urban structure with a slow pedestrian speed. You see, this was slow and everything had to be kept together, organized in a smart way. This is the wonderful variety of our historical city and in a beautiful manner. But today you don't need it. If you have a car, you can move very fast and satisfy your need somewhere else. The effects are urban sprawl, scattered cities, and a huge amount of energy is necessary for this kind of movement because physics is always valid. And when you are driving with your car on a motorway with 130 kilometers an hour, then you burn about 7 to 8 liters only to push the air in front of you. Is this a progress? Okay. So, what is happening now if we have in our brain car data, which were put in my brain when I studied, and is put in your brain when you are studying civil engineering or economy or whatever it is. Then you have the car in your brain, and everything what you are doing is for the car. You are not doing any more cities for the car, you build a car structure, as I've shown before. And if you build a car structure, the people are intelligent and selfish, and they read the environment, and they say, okay, wonderful, I am car addicted. I want to have a car and I want to use it because everything has been prepared in a perfect way for me. And then they are wondering that they have congestion and then they have accidents. This can be done with very nice formulas. They are nonlinear relationships, so we are in a very complex situation. And this is what we are producing since 50 years. So when we have congestion, then we build more motorways. We build one ring road, and if it is congested, we build a second ring road. And then it is congested, they will build, and so on and so on. You can continue this kind of principles. We are doing it in the West also since decades. But the effect today is known, can be calculated and forecast. So, the question is, there was always the question, is it true only there or only here? This is the global survey carried out from IASA and MIT in the 90s, in the last century. On the horizontal axis you have the GDP per capita, and on the vertical axis you have the travel time budget. This means these 3 or 4 trips per day, how much time the people need, or how much time the people spend in the system. And if the people on the left side have no cars, they have no money, we have a lot of cars, and you are also running into this direction. The people on the left side have a pedestrian speed, and we are very progressive, and we have fast speeds. So we would expect to have this travel time budget. This is our calculation. On these calculations, all the investments globally for fast transport systems are based. They are based on travel time savings. But in the system, travel time is constant, as I've shown you before. Can you lose travel time? Can you lose time in a congestion? Does a system lose time in congestion? This is a question. I'm asking you the question. Yeah, even the EU is calculating 1 or 2% GDP loss from congestion. No, because a system which cannot gain time by increasing speed cannot lose time by decreasing speed. And congestion is decreasing speed. As Dinesh has said before, congestion is a safe situation. If we have a long congestion, nothing can happen. So, you see, the situation is totally changed when you understand the system. You don't fear congestion. You use congestion as a tool to help the people to escape from the car and use the bike, use the public transport. I'm doing it with the politicians in Austria and other countries since decades. We cut off lanes of cars to give them to the trams. And the cars who are driving beside the tram have to stop at the tram stop because we extend the sidewalk to the tram, that the people and the handicapped people with a wheelchair can evenly go into the public transport. If you come to Vienna, you will see it. Well, not all of them is made by me, but my students are doing it already since decades. So this is happening. So travel time budget is the same. It is a wonderful tool for qualified engineers because qualified engineers use congestion as a tool. It is an elegant one, but it's a kind of treatment. If you have another opportunity, it is a very good situation. I show you the effects. This happened in Vienna. Sorry. This motorway was built. Beside the effects that the motorway is increasing the number of car trips, it has also some effects on traffic safety. When this motorway was built, the promise of engineers was that the parallel road will be relieved from the heavy traffic they had before. This was the situation before. This motorway was opened, and now the number of cars on the parallel road went down from 22,000 cars a day to 7,000 cars a day, but 10 years after, the situation has changed. This was the traditional view to the system. 10 years after, on the same road, we had more cars, plus 80,000 on the motorway. And since the folklore is continuing, our ministry has now built for a 4-lane motorway to an 8-lane motorways, and we are producing 200,000 cars on the motorway, and the congestion has increased. So if we build more lanes and provide more opportunities for cars, you are producing always problems and accidents. So this is the situation, this is the system behavior, this is how the system works in reality, and this is the very interesting analysis. You see in Vienna the number of accidents has gone down continuously, like in the whole country, and in 78 you see a hump happened. And this was the opening of the motorway. Because the motorway took off some trips from the urban roads. What happens if you relieve the transport in urban roads? Speed goes up, energy is increasing also, and what is happening in this case, you have more accidents, and it needs about 16 years and 15,000 injured people till the situation was stabilized again. So you see how the system works. Well, this is a very simple formula. This is a number of accidents, is risk, individual risk of any mode. I is the mode, D is the number of users, pedestrians, cyclists, and whatever it is, and V is the speed. And if we want to change the number of accidents, we can reduce the individual risk by technical means, by education. We have heard the whole day what we can do. Or we can reduce the number of risky participants in the road, and we can reduce the speed. These are the three opportunities we have. And if we look how risky, how much risk the different users are bringing into the system from physical terms, because accidents have very much to do with physics, we cannot escape. And you see it is the car which produced the accidents. And if we take into account a little bit also risk factor, we have a similar situation as you have heard it today many times already. So what is happening here, the car goes with 240 horsepower in our body, because we have not anymore the feet on the ground. The wheels are on the ground, not the feet anymore, and the brain is not prepared for this situation. What is happening, this situation goes into our brain, and then we have the situation, if we park at home, we don't need any working, any shopping, and any recreation nearby, because we can compensate all the deficit of a poor urban planning by using the car, because we can drive somewhere. And this is the secret of the urban sprawl. This is the secret of these monofunctional structures in the cities, the effect of land use planning, and some of the effects is also the accidents. So parking at home and the destination have no chance for public transport, and you have a dangerous environment, especially for vulnerable road users. Because if you have the car at home, as soon as you are going on the street, you produce a risk for all the others, especially for vulnerable road users. This is not a question of traffic engineers, because traffic engineers are mainly focused on traffic flows. This is a question of urban planners. So the main power to change the behavior is to change the urban structures. So this is the situation. If we have a car at home, you see we have 100% risk probability, and this creates a car-oriented environment, and decision of model speed is happening at the origin and destination. Here we can decide if we want to live in a safe environment or if we don't like to live in an unsafe environment. It is much more convenient, at least for car users. It is absolutely inconvenient and risky for vulnerable road users. And this is now the question every planner must decide what he is doing. Does he prefer convenience or life? I think it's not so difficult to decide. So this is the environment we have built, and accept it, because the car is in our brain and control the view to the globe. Or we build garages, which is even more expensive. And then we build this kind of public space. This is not public space. This is a danger for everybody who has not a car. So the solution is we have to remove the cars. Otherwise, we will not reach zero vision. Zero vision becomes reality if cars are removed from the cities. Then we have a sustainable city. Living and work and shopping and leisure is coming back, because it must come back if we have a low speed. The functions must be close and around you, and you must have a big variety and working opportunities. So this is a safe urban environment, and this is the situation. This is the same situation. If you can imagine, if everybody who has here a bike would park with a car, you can switch the city. Okay? In Vienna, it's on the way a little bit. It is since 10 years #1 quality of life. This is a small contribution to quality of life. Each colored area, which is not green, these are the built-up areas beside 3 districts, have no free parking anymore. If you go to Vienna, you are a short-term parker, and you have to pay every hour 2.10 euro, which is only half of the price which should be collected. And this helps very much the people to go to other modes. And we have a 365 euro annually public transport ticket. So 1 euro for all the public transport trips you want today per day. So the number of public transport annually ticket holders has increased from 360 to over 900,000 in a 2 million city. So every family has. And what is interesting, the people are not stupid. They learn to read the environment, and they have recognized, well, it is better to live in Vienna without a car. And the motorization is going down since the 1990s. Already car use has gone down, and 10 years after, the Viennese people, especially the young people, give up cars. And more young people don't even have driver licenses. And this is the next step toward more safety situations, and it's interesting to have the safety effects also. And I will show you what happened in the this was the situation in Austria, rural areas. Oh. Okay, Vienna was in 1999. Here is the traffic deaths per population, million population, or whatever it is. This was Vienna 1999, and you see even in a high motorized city, Vienna has about 380 cars per, it is declining, 380 cars per 1,000 inhabitants. We were able, due to putting our interest on parking and restricting parking, we have an increase in traffic safety. We are now down since 2030 about on this level. And you see this is the core effect, because the core effect is the man, it is not the car. We are going into the brain of the car. We use the brain of the people and help them to escape from the car. This is the most important thing. So, and you see this is a nice picture, but it's not mobile at all. Therefore it is nice. Thank you.